Okay, we're back. Gonna go a little quicker on this one. We've seen questions like this already, so a little less explanation, a little more moving along. And here we go. So we've got square root of 8 over 50. We're gonna take, let's simplify that. I'm gonna divide top and bottom by, let's see, 5, 2. We're gonna try 2. 4, does 4? I do not think so. I'm going to try dividing top and bottom by 2. So divide top and bottom by 2, I get 4 on top, and I get 25 on the bottom. Perfect. That's going to work out nicely. We can take the square root of the top and the bottom, and we get 2 on the top, 5 on the bottom. Simplest form, already done, no more simplifying needed. Next. Question number 29. To the nearest whole number, what is approximate square root of 160? All right, we've done questions like this again before. So we're looking for that perfect square. We've already seen that 14 squared we know from before is 196. That's a little too high. And I think we calculated this, but I don't recall what it was. So let's try it again. So 13 times 13 is going to give us 130. Let's just do it. Okay, 9, 3, 1, 3, and oops, 3 and 1. So 169, I do recall that now. That's very close to 160. 12 squared, if you know your 12 times tables, is 144. So 169 is definitely going to be the correct answer. 144 is way over here. 169 is here, giving us a square root of 12 here of 13. So 169 is very close to 160. So that's going to be our square root to the nearest whole number. So 169 gives us 13. 160 would be here, be a little bit less than 13 as a square root. So it would be 12 point something, but close to 13. So 13 is our square root. That is the closest. Okay, next question. To erase this so we can see it. There we go. So what is 250% of 40? So 250%, we could break that up into 100% of 40, another 100%, 40, and then 50% of 40. 100% of 40 is 40, the whole thing. 100% of 40 is 40 again, and 50%, which is half of 40, would be 20. So 80, 40 and 40 is 80, 80 and 20, 100. There we go. Next question, what is 75% of 160? Okay, so we could do this one a couple ways. One, I could change this to a decimal, 0.75, and multiply by 160. So let's see here, I'm going to do my multiplication. 0.75, 5 times 0, 0, 5 times 5 is 30, 0 carry the 3, 5 times 1 is 5, plus 3 is 8. Move 1 digit place over, so we can put a placeholder there. Then 7 times 0, 0, 7 times 6 is 42. There's my 2. I'm going to carry the 4, and 7 times 1 is 7, plus 4 is 11, and we have 2 decimal places here. So my answer is going to be 1. Oops. 8 and so 0, 0, 8 and 2, 10, 1. So we have 2 decimal places to account for. So my answer there is 120. Another way we could do it though is 75%, oops, is same as 75 over 100. Also, think about a dollar. If you have quarters, how many quarters do you have in a dollar? Each quarter is worth 25 cents. If you have 3 quarters, you have 75 cents. That's 3 quarters of a dollar. So If we divide top and bottom by 25, we could write this as 3/4. So we could do this as a fraction. That might make life a little bit easier to calculate things. So instead of saying 0.75 times 160, okay, I could also say 3/4 because I can write that decimal, that percent, as a fraction. And I did that because I can see that when I multiply by 160, I've got something here that I can easily divide. I can see, I recognize that 4 divides into 16, so it also divides into 160. So if I divide top and bottom by 4, I can get, this reduces to 1, and 160 divided by 4 would reduce to 40. 40 times 4 would give us 160. 3 times 40 is 120. 1 times 1 is 1. That would be on our denominator, but we don't need to see that there. So you could also do that by converting it to a fraction. Again, going to the decimal route, it's something that you're probably accustomed to, and if that's easier for you, just go ahead and do that. Okay, next question. Question number 32. Okay, very similar to one we saw before. I could convert this to a fraction with a common denominator of 5, or if I realize I have this 5 in my denominator here and I use my distributive property, I can multiply this here and multiply that there. So 5 times 3 is going, so we get, and I'll maybe just write it out so you can see that 5 times 3 plus 5 times 2/5. Okay, there it is. We distributed that 5. We multiplied it to each part. And then 5 times 3 is 15. And here at 5, we can divide by 5, right? And we get a 1, so we get 2/1, or this simply just 2. We cancel those 5s out. 15 plus 2 is 17, and we're done. I'm going to have to erase some of this here. Okay, next one. Same situation. Look at this. Again, 6 in our denominator. So why don't we multiply by 6 here? Okay, to get rid of that. So 6 times 2 is going to be 12. 6 times 1/6 is just 1. You need to see that. Write it on the side or do it somewhere so you can see that. Oops, not what I wanted to do. If I multiply 6 times 1/6, that's the same as 6/1. 6 times 1 is 6. 6 times 1 is 6. 6/6 is 1, right? So 6 times 1/6, that's the same as saying 6 divided by 6. This gives us 1. Don't forget we were doing addition. We're adding those together. 12 plus 1, we get 13. Get rid of that. Should I do this just for fun? Okay, we could. So the other way though, let's call that method 1 here, method 2. Again, the other way you could do this would be to just leave your 6. And this just means multiply. We don't need to see that if we got brackets, right? We know that means we're multiplying. I'm just going to convert my 2, this is to something over 6. So I multiply top and bottom by 2. 2 is the same as saying 12/6, right? 12 divided by 6 is 2 plus 1/6. So now I can add that. I've got 12 plus 1. We're still inside my brackets. 12 plus 1 is 13. We have the same denominator of 6. And we can divide. 6 divided by 6 is 1. Well, that basically cancels out, and we've got 13. Okay. One more exact same setup on this one. So here we go. Multiply that. 8 times 4 is going to give us 32. Plus 8 times 7/8. We know the 8 is going to cancel with the 8. Leaves us with a 7. 32 plus 7 is 39. And there we go. I did that one a little quicker. You can take your time. You can write it out step by step like this. Okay. You can put this as a fractions with a common denominator and then multiply. You know, just do what works for you as long as you're getting the same answer. Okay. Remember, part A, numerical response. You're going to have to type your answer in, and it needs to be the correct answer. So if you got there, by a different method, that's okay. All right. Carrying on. What is the integer answer to the following questions? All right. So when they say what is the answer, they're saying evaluate. They mean they want the actual number. So we're going to simplify. If we end up getting something like 4 to the 3, we're going to have to calculate what that is and give an actual answer, right? Okay. So let's do it. So we have this situation again. Here we are multiplying exponents because we have an exponent to an exponent. So 4 times 4 would give us 4 to the power of 16. And then we'll multiply that by 4 squared. And here on the bottom, I don't see my exponent, but it's 4 to the 1. So I'm going to add my exponents. So I have 4 to the 1 times 4 to the 16. I can just go ahead and I'm going to do that step right away here. So 1 plus 16, 4 to the 17. Now I'm going to do this part here too. So I've got 16. Now we're multiplying, same base. We're going to add exponents, right? When we multiply these together like this, we add exponents. When it's brackets with a power to an exponent, that's when we multiply the exponents. Here, we don't have an exponent to an exponent. We have a base to an exponent, the same base to an exponent. They're both 4. Since they're the same base of 4, we can add these together. Okay, so we add, so we get 4 to the 18 over 4 to the 17. And now we divide these. So we take, when we're dividing 4 to the 18th divided by 4 to the 17th, we subtract exponents. So we'll be left with, let me just go down here, 4 to the 1. And 4 to the 1, we don't need to see that exponent. 4 to the 1 is just 1. So on your answer sheet, you would type in the number 4. Okay, next. Once again, this is multiplication because we have an exponent to an exponent. So we're going to get 3 to the 5 times 4. 5 times 4 is 20 times 3 to the 3. On the bottom again, remember, that's a 1. So now we have 3 times 3 to the 1 times 3 to the 19. We add exponents. We get 3 to the 20. Now, I could add these together. So we're multiplying, so I could add my exponents. And I'd get 23, and then I'd take 23 and subtract 20 to get 3 to the 3. But I can also see that these are being multiplied together, then divided by 3 to the 20. I can just divide those out by 3 to the 20 each, like we've done in other fractions. So we can cancel those out, and we're just left with 3 to the 3. Or we can just do it we'll do the whole procedure so you can see. Sometimes you got to be careful when we talk about this word canceling. You have to understand that when there's things like addition or subtraction involved, you can't just cross things out like that. Only works if we have everything in the numerators all being multiplied together, okay, when in the denominator the same, or something, just a single term like that. But let's just do it this way. So we're going to follow this rule maybe to keep things a little straightforward for some. So we're going to add those exponents. So we get 3 to the 23 over 3 to the 20. Now we do the other rule, 3 to the 23. So we're going to, because we're dividing, that means we subtract exponents. So 23 minus 20 is 3, same as we had just a second ago. Now, let's see, they didn't give an, oh, it did say, yeah, answer. So we need the actual answer. So we're not done yet, okay? So we have to actually calculate that value. So 3 cubed is going to be 3 times 3 times 3. I'll let you calculate that yourself, but you should get 27. 3 times 3 is 9. 9 times 3 again then is 27. Okay, there we go. Next one. Okay. All right, a little more going on in this one. So let's do what's inside our brackets first if we can. We're multiplying, so that's good. We have an exponent here. We don't see it. We can, pardon me. I ain't editing that out. I have things to do here. So just pardon me. So 2 to the 4 times 2 to the 1. So we're going to add exponents. 4 plus 1 is 2 to the 5. Okay, remember though, that's what we did inside the brackets. Don't forget we had this little guy out here, so we need to leave that there. Okay, and then let's just write the rest in. Remember, I like to use dots instead of times. I think it's just like neater, and we don't confuse them with X's. And to me, that's clear that that's multiplication. Here we have nothing else going on except these two being multiplied together. So let's just do that now. So we're going to add 8 and 2. So we get 2 to the 10. Okay, now let's just do this step here. 5 times 2. Remember, exponent to exponent, we multiply. 5 times 2, so we get 2 to the 10. Okay, keep that part from before. Once again, we're in this similar situation. I could just cancel these out, and I'll be left with an answer of 2 to the 5. Or we can just prove that this works if we do it the other way. We're going to add these two exponents. Okay, so 2 to the 10 plus 5 is 15. So 2 to the 15 over 2 to the 10. Then we're going to subtract these 15 minus 10. And we are going to get 2 to the 5. All right, same as if we would have just canceled those out. Okay. So answer is 2 to the 5, and then we have to calculate that. Take 2, multiply it by itself 5 times, or if you've memorized some of your powers of 2, there you go, 32. How close are we? We're almost done. We're going to finish this in this one video. All right, we have 5 more questions to do. We're evaluating these all. So here I have 12 on the top, nothing to do there just yet. I'm going to do my math inside the brackets. First, 4 minus 5 is going to give me -1. Okay, that should be natural to you now. If you're not sure how I got that, take your time, practice those addition and subtraction of numbers with different signs, pluses and minuses, and so on. Okay, so this, remember, this is -1 times -1 times -1 3 times, or if you recall, this is an odd exponent. Okay, so that means that we're going to have a negative result from this. So we're going to have 1 cubed with a negative value. So we've got 12 over -1. And since if I divide, so I'm dividing 12 by 1, that's just 12. And if I'm dividing a positive number by a negative number, it's going to be negative. So my final answer is -12. So if you would be writing that into your numeric response, you're going to have to type that exactly, right? -1, 2, just like that. All right. Okay, next up. Okay, on the top, 19 plus 1, 20. Easy. Let's do our brackets. 5 minus 7, -2. And it's squared. Okay, so squared, that is a positive, sorry, an even exponent. So it's going to give us a positive result because it's going to be -2 times -2, negative times negative. It's positive, right? So 2 squared is 4. Even exponent, it's going to be a positive number. And we get 20 on top. 20 divided by 4 is 5, and we're done. Next question. 36 on top. 2 minus 5, -3, squared. It's just there. So 3 times 3, 3 squared is 9. This is, remember, this is applying to the whole thing, right? So when this exponent is applying to the brackets, that means we're multiplying this twice. And that's why we get a positive number, negative times negative, right? An even number of times of that negative sign is going to give us a positive value. Okay, so that gives us positive 9. 36 divided by 9. Think of your times tables. 9 times 4 is 36. So 36 divided by 9 is 4. And there we go. Last 2 questions. Okay, again, similar. So there's just more practice of this type of question. We're going to take square root of the top, 1. Square root of the bottom, 2. So we get 1/2 there, times. These are both perfect squares, so that's easy. Square root of 16 is 4. Square root of 81 is 9. Times. Now we've got 81. The square root of 81 is 9. And now we have how many zeros? We have 4 zeros. So we know from before, I have to have 4 zeros before to get 4 zeros afterwards, right? 1, 2. So 100 times 100 is 10,000. Okay, so we're going to have 9 times So 9 times, sorry. So we get the square root of 81 is 9. The square root of those 4 zeros is going to give us 2 zeros afterwards. So we're going to get 900. Okay. So we get half the amount of zeros, right, when we take the square root. Now we're going to, let's find some things in common here. We can divide this top and bottom by 2. So I can divide by 2 here and get 1. I can divide by 2 here and I get 2. And I see in 900 divided by 9. I can divide 900 by 9 and I'll be left with 100. And here divide that by 9 and I'm left with 1. So I'm going to get 1 times 2 times 100 is 200. And on the bottom, 1 times 1, we don't need to see that. It's just 1. 200 divided by 1 would be 200. Okay. Last question. Square root of 1 over 25. Again, is that a perfect square? Yes. 1 times 1 is 1. Perfect square? Yep. 5 times 5 is 5. So we take the square root of the top, and we get 1. Square root of the bottom, and we get 5 times. Again, perfect squares. Square root of 100, 10. Square root of 49, 7. Square root of 49 is 7. How many zeros do I have? 1, 2, 3, 4, 5, 6, 7, 8 zeros. So if I take the square root after, I'm going to have half the amount of zeros. So half the amount of zeros is 4 zeros. 1, 2, 3, 4. So 70,000. All right, I'm going to do some canceling. I can divide 5 here and get 1, and divide 5 on the top and get 2. Divide top and bottom by 2. And here, divide top and bottom, right? This is, we don't see it, but it's over 1. That's like a top of a fraction, that's a bottom. So we are going to get, we're going to divide top and bottom by 7. 7 divided by 7 is 1. 70,000 divided by 7. It's going to leave us with 10,000. So we have 2 times 10,000 is equal to 20,000 over 1. We don't need to see the 1. Answer is 20,000. Let's just go have a quick look and see how we did on all those. Okay. Okay, they did some of these a little bit differently. So as long as it makes sense to you, it's nice and compact. So you can do it any way that works for you. And it looks like all of our answers agree. And that's it. That's it for the first part of your Part A review. If I have time, I'm going to do video solutions for the second part as well. So there's the second part that was posted in Classroom. But first I have to see about uploading these to YouTube, somewhere where you can view them. All right, good luck with your studies. Got this evening and tomorrow evening to get studying, 2 more nights, and then Tuesday morning, Part A of your grade 9 PAT. Good luck, everybody.